Now we will discuss about the potentiometer. So there is an instrument known as potentiometer. So it is an instrument to measure the EMF and to compare the EMF of the two cells, and it also helps us to determine the internal resistance of the cell. Now, potentiometer, how it has been made, generally it has 10 wires. So the potentiometer will have 10 wires. Each wire is of 1 meter, so generally it is of 10 meters. Now these two ends will be connected to the source of the EMF of the very source, and then we will also use the cells, the primary cells, which we are going to determine. So the EMF of those cells. Now potentiometer, what is the principle of potentiometer? The principle of potentiometer is that whenever there is a constant current flowing through any wire, uniform wire, then the potential drop across the length of the wire is directly proportional to the length of the wire. For constant current flowing through any uniform wire, the potential drop across the length of the wire is directly proportional to the length of the wire. That is, the length of the wire is L, then the potential drop V will be directly proportional to the length of the wire. Therefore, V equals to constant K into L. What is K? K is called potential gradient. So what is K? K equals to V by L, that is volt per meter. So the potential gradient, it determines the sensitivity of the potentiometer. It also determines how much sensitive is the potentiometer. That when the current is less, then the sensitivity is more. So when you increase the length of the wire, when you increase more length of the wire, then the sensitivity will be less. Right? So that is why in potentiometer we will have, how do we determine this? So the balance point should be always on the last wire. Why? When you will increase the length, then when the length will increase, then your potential gradient, because we have maintained it less, so then the reading will be more accurate. So while using this instrument, if we get a balance point on the first or the second wire, that reading is not accurate. The balance should be always on the last or second wire. We should try to increase the length, balancing length. What is the balancing length? The balancing length will be the length of the wire at which we get the null point. What is the null point? When there is no deflection in the galvanometer, that is, no current flowing through the galvanometer, as we have done in the meter. So in this case, the potentiometer is used for comparison of EMF and to determine the internal resistance of the cell. So what are the uses? To compare the EMF of two cells and to determine internal resistance of the cell. Now, why we prefer the potentiometer in calculating EMF, not the voltmeter? The voltmeter will draw some current, and hence we do not get the value of EMF, since EMF E equals to V plus IR. Now when we are measuring through the voltmeter, then actually we are drawing some current. So when you take out some current, then you will not get the accurate value of the EMF. While in this case, in potentiometer, we do not draw any current. At balance point, there is no flow of current through that branch. So this is zero, and hence whatever we measure, that is the EMF. That is why the potentiometer is preferred over voltmeter to measure the value of EMF. Let's understand how to compare the EMF of the two cells. Okay. So as we know, the potentiometer will have 10 wires. Now, these two ends, they are connected to an auxiliary cell which will provide, and then there will be a rheostat, and through rheostat we will connect here to here. Now, we will connect the two cells. The balance point should be always on the last wire. That is why we draw the jockey on the last wire. Now here this is the first cell, EMF E1. This is my second cell, EMF E2. Generally in the laboratory we use Lackland cell and Daniel cell. So there we can connect in this way. One of the cell is Lackland, another will be Daniel. There will be two-way key. So K, T1, T2. This is RB stands for resistance box. This is the galvanometer and it is balanced over here. This is my auxiliary battery and this is my rheostat. Now, the first is to compare the EMF. For comparison, we will have to connect in this way. Now, we know that since what is the principle of potentiometer? The principle of potentiometer states that for uniform current through a uniform wire, the potential drop across the length of a wire is directly proportional to the length of the wire. That is, V is proportional to L. That is, V equals to KL. Now, in this case, therefore, EMF E equals to KL1, the potential gradient K, and E2 equals to KL2. So this is equation 1, this is equation 2. Divide equation 1 and equation 2. So E1 by E2 equals to L1 by L2. So by this method, this way, we can find out the ratio of the EMF, or we can compare the EMF of the two cells. Now how to determine the internal resistance of the cell? Resistance of a cell, right? Now let us connect how to connect. These are all the experiments that we are supposed to do in the lab. So 10 wires, these are the two ends. Now this is your industrial. You want to connect it to, or you don't want to connect it to, it's okay. Then connect the light here. There will be shunt resistance, shunt. There will be two. Resistance box, there will be galvanometer, and then the balance point will be at the middle. Right? Now, this is for the determination of internal resistance. Now, in this case, when the key is open, let the balance point is L1. So, when we are not using this shunt, so shunt is basically the alternate method to allow the current to pass through it. So what will happen? Then in that case, E equals to KL1, where K is the potential gradient. The K should be constant, and the K determines the sensitivity of the potentiometer. When we say the sensitivity is more, when the balancing length is more, when the L is more than the sensitivity, we say that the sensitivity is more because the current is less. Now, E equals to KL1, this is the expression for when we are not using the key, when we use the key, then there will be a potential drop, and that V equals to Kn2. So now, therefore, E by V equals to N1 by N2. Now we know that E equals to V plus IR. So V plus I into R divided by V equals to N1 by N2. So what is V? V is I into capital R. So therefore we can write I capital R plus I into small r divided by I into capital R equals to L1 by L2. So I is common, so 1 by small r by capital R equals to L1 by L2, or small r by capital R equals to L1 by L2 minus 1. So small r equals to capital R L1 minus L2 divided by L2. This is the formula to determine the internal resistance of a cell. So potentiometer is the only one instrument with the help of which we can determine the internal resistance of a cell. And while doing experiment in the lab, the problem will be in the measuring the length. So how to measure the length? The end where you will connect the positive terminal of the cell, that will be treated as 0. So the 0 will start from the point where the positive terminal will be connected, and so reading will start from this end, right? So while doing experiment, there is a chance of error in measuring the scale. So it will cost us at that time. So you will have to look into where you have connected the positive terminal, and then you can do it. Now if anybody asks us why we use potentiometer, not the voltmeter, to measure the EMF, so because the voltmeter draws the current, and hence we do not get the value of EMF, while the potentiometer does not draw any current at the balance point, and hence we use the potentiometer. Okay.